Welcome to Brain Vision.
Chapter 1, Section 7, Problem 24. For the vectors a and b in figure e124, as I have drawn here, it says, use scale drawing to find the magnitude and direction of a, the vector sum of a plus b. So we'll begin with that. And so the one thing we learned from the vector section is, how do we add these vectors together? So we'll begin with a. The way you add vectors is you first start with the beginning to the end, and then you add the component of the b vector. So this vector could be shifted in any direction, in any translation. So we could begin by starting off going down 8 of vector a, and when we add, we continue on from here with vector v upwards 15. So this isn't exactly drawn to scale at 30 degrees for vector v. And so the way this summation works is our final vector right here goes from the beginning to the end. And this is our vector a plus b. So at least in terms of a drawing, this gives us an idea of what we kind of have going on, but it doesn't really tell us all the information we want to know. Like, what are the angles of this and what is the magnitude of this? And so that's where basic trigonometry comes into play. And as we see, we're going to need to use the law of cosines. Yes, we need to pull this out from our old trigonometry training. And we'll redraw the triangle real quick. This is our basic triangle. And in this case, our side right here was 8, 15, and we know the angle here was 30. And so what we want to find out is the magnitude of the a plus b, which is this one. So in this case, this is going to be c here. And from this triangle, we can see that a is going to correspond to the 2 to the 8, b will be to the 15, and we just plug in everything. And the c corresponds to the 30 degrees that is opposite of c. And so when we plug this in, c is equal to the square root of this. This is a quantity square. So we want to find c by itself. And that's going to be 8 squared plus 15 squared minus 2 times 8 times 15 times cosine of 30 degrees. And remember, it's 30 degrees, not 30 radians. Your calculator might start off default with radians. Just make sure to check that. So if we were to plug all this into our calculator, we find that c is actually a nice number. It's equal to 9 right here, approximately 9. Better yet. And so that's great. We now found our magnitude for a plus b. But the thing is, we don't know the direction. Vectors have a direction and a magnitude and direction. And so that's where the next part of trigonometry comes into play, the law of sines. This is a good relationship that can give us all these quantities. And so if we draw the triangle again real quick, we now know that this is about 9, this is 8, and this is 15. So we know this angle's 30 degrees. And we want to find out the angle, this angle, as it would correspond away from the x-axis. We had our y, this is x. So we just want one of this angle in particular to find out the direction. And so based on the law of sines, we would then use this quantity. So we use these parts of the equation. So we'll have sine of 30 degrees. This part, we'll just do the c part first. to 9 is equal to sine of this angle, which we'll just call B for now, over 9. That corresponds to this one. Oop, 15. Okay. The way we solve this is using our handy dandy calculator once again to solve for B. And we do that by actually using the arc sine, which is the inverse function to get out the value of what this normally would be. And so it'd be the arc sine of, multiply this to the other side, 15 divided by 9 times sine of 30 degrees. So the answer for this ends up being 56.4 degrees right here. All right. And so we basically have our magnitude, which we said was 9. And the direction of this vector from at least this bottom part is 56.4. And so the vector is pointing in that direction away from this quantity. And if we want to say the angle away from here, then it would just be the 90 degrees minus this. Okay, and so that is for A plus B. The vector is A plus B for part A. For part B, we're going to want to find it for A minus B, so the vector difference. And so first thing we have to find out is, or we have to realize is, this is the same as vector addition of the negative vector. And so the negative vector V just corresponds to, B corresponds to the negative in this direction, negative B. Still has the same magnitude of 15 in the opposite direction, and is 30 degrees away from here. So when we actually look at it in a larger view, we go down 8 for A, and then we go 15 in this direction at an angle 30 away from here. And since lines are 180 degrees, that means that this angle inside is 150 degrees. And so our triangle looks like this. See, this is a longer section. And so based on what we had, so I'll redraw the triangle right here. So we know this angle is 150. This is 15. This is 8. And so we want to find the side C right here. So we do the same thing. We literally use this exact formula where it's 8 squared plus 15 squared minus 2 times 8 times 15 times cosine of 150 degrees. Just in case you're not familiar with this notation, if they put a dot here, that means times. So what we get for here is we get about 22.3 for C. So that gives us the length. But when we want to calculate the sines, we do the same thing with the same process of the law of cosine. So we have 22.3 here, and this angle is 150. And we want to find out this angle, which we'll call B again. angle does that correspond to? 15. And so we do the same thing with the arc cosine, or the arc sine. We find out that B is equal to 19.66 degrees. And so this angle's 19 degrees. And so this would be our vector A minus B. Okay. So the next task we're given, it says use the answers to find the magnitude and direction of minus A minus B. First thing to realize is there's something really nice about this. There's the minuses here, which means you could pull a minus out. And so what we get is negative A plus B. And what we had calculated was we had a vector like this last time. So it's literally just the opposite. And so the magnitude is the same. It's about 9. And the angle we calculated was about 56 here, which means it's 56 above here. Or the opposite, like we said, 90 minus 56 from here. So this angle is 56. And so the same thing with the other one where it says B minus A. We do the same process. We notice that there's technically a plus here and a minus here. So if we take out the negative, we actually get minus B plus A. And the cool thing about vectors is that the commutative property holds, which means you can move these to the other side. So it gives you A minus B. And same thing like last time, where quantity we have with this really long vector that goes down, since it's negative, it just goes the opposite. And so we said C was, or the distance of this was 22.3, about 22. And so now the angle here is the same angle as before. The angle here was the same as before, which is about 19. And so later on in exercise 1.31, there's a different approach. And so you don't have to use all this trigonometry. You just have to know the components of each of these vectors, which will be a lot nicer.